Transport the embedding, don't invert the image. Composed image retrieval is the task where you hand a model a reference photo and a text instruction, like make it red, and ask it to find the target image. The standard approach squashes the photo into a few pseudo-text tokens, losing fine-grained detail, and burns hours of high-end GPU training to learn that squash. FlowCIR from HKUST and HKU reframes retrieval as flow matching. It learns a tiny transport field that slides the instruction embedding toward the target, conditioned on the reference image. Half an hour of training on a single consumer GPU, and top retrieval scores across every cutoff. The forward pass. Take a reference image and a text instruction. Freeze a clip image encoder and a clip text encoder, both stay fixed. Sample a time step on the unit interval. Interpolate between the instruction embedding and the target text embedding along a straight line. A small velocity network, conditioned on the reference image, predicts the transport direction. Take one Euler step to land on an estimated target embedding. Pull the nearest neighbor out of the gallery. That is the whole inference. Transport the embedding, don't invert the image, the gap it fills. Textual inversion compresses a rich image into a handful of pseudo tokens, then concatenates them with the instruction in text space. Two problems. First, that compression loses fine-grained semantics. The photo is reduced to a blurred word. Second, training that projector needs hours of multi-GPU contrastive learning on web-scale data. FlowCIR freezes the encoders entirely and trains only the lightweight transport module. The reference image never gets squashed into text. Its features condition the flow directly. The falsifiable hinge on table 3. Add flow matching and retrieval jumps. Mean average precision at 5 climbs from 3.3 text only to 14.9 with the full model. A 4.5 times jump from one design choice. And it is not optional. Strip the conditioning on the reference image, and the theory says the unconditioned flow collapses to the mean of every plausible target, which is not any single real image, so it cannot recover the right one. Conditioning on the photo is provably necessary. Flow matching, conditioned on the reference, is the active ingredient, how the lead holds across recall on table 1. CIRCO mean average precision at the top 5, 10, 25, and 50. FlowCIR leads at every single cutoff, 14.9, 15.7, 17.3, 18.2. The strongest public data baseline, LIN-CIR, sits below at 12.6, 13.6, 15, and 15.9. Compo-diff, trained on 128 high-end GPUs for 231 hours, ties or trails a half-hour run on one consumer card. Here is the payoff in pictures. Before, a reference photo of a plain white sneaker, plus the instruction, make it red. After, the retrieve target, the same shoe in bright red. The model never edits a single pixel. It transports the query embedding to where the red sneaker lives in the gallery, then pulls that image back. The instruction and the photo together point straight at the target. Why flow matching and not a plain regressor on tables 4 and 5? A direct regression head that maps the instruction straight to a target embedding scores 23.8 recall at 1. The flow matching transport scores 26.2. The time-conditioned velocity field beats a residual regressor by 2.4 points because flow matching respects the geometry of the embedding manifold. And transporting into the text embedding space beats the image embedding space, 26.2 against 23.8. The design choices each carry weight. 5 honest caveats. First, FlowCIR loses to heavier resource methods. MagicLens, trained on 64 TPUs with 36 million private triplets, scores 29.6 on CIRCO, roughly double FlowCIR. Second, on fashion IQ shirt recall at 10, FlowCIR is dead last among public data methods. The average win is carried by dress and top T. Third, the multi-negative steering, the second contribution, adds only 1.4 to the score. Flow matching does essentially all the work. Fourth, the half-hour versus 2 on 31 hours cost headline is hardware inequitable, different GPUs, not apples to apples. Fifth, no seeds, no confidence intervals, single-run deltas under 1 point. Cite the paradigm shift, not a retrieval crown. Transport the embedding, don't invert the image. FlowCIR reframes composed image retrieval as conditional flow matching, sliding the instruction embedding toward the target, conditioned on the reference photo. Top retrieval at every cutoff, a 4.5 times jump from flow matching alone, and half an hour of training on a single consumer GPU. Subscribe for the next breakdown.